All right, we're gonna skip 3, 4, and 5, and we're gonna go right to equipment. This chapter discusses the basic equipment used for rappelling operation. Appendix D discovers the type of the ropes, the procedure for the rope selection, and the care of each rope type. Also discusses two methods of coiling different snap links used to join equipment. Ropes are most important items of the equipment for the propeller to provide access down obstacles aerial platform while ensuring individual safety. Type 6.1 Type of ropes. Two types of ropes are available for the propeller: static and dynamic. Static rope, the rope allows minimal stretch for the rope. The static rope stretches about 5 to 15% of the point of failure, is about 2% under the working load. The minimum tensile strength of the 11 millimeter static rope for the military use with the 4,500 pounds. The Kernel metal mantle static rope with a range of 3 millimeters to 11 millimeters diameter, construction similar to the 550 parachute cord. Kern means core and mantle means sheath. The internal core of the rope is constructed from the continuous multi-filament nylon yarn, which is spun into continuous parallel strands. This internal core is covered with a nylon braided over the sheath. Due to the internal parallel strands, the construction of the static rope, there is less spinning and kinetic hinking through a dynamic rope. Static ropes can be used for slings, harness, interior stirrups, tappling rope, installing hauling lines, or whether stretch of the rope is not inserted. Dynamic rope. The rope allows you to stretch for the fibers of the rope that can be disadvantaged in the rappelling, precision climbing, and other applications. Dynamic rope are more susceptible to abrasions and wear. They have about 5 to 10% of working stretch, minimal tensile strength for 11 millimeter rope for military use of 4,500 pounds. The two types of dynamic ropes are nylon laid and kernel mantle. Nylon laid ropes, synthetic fibers are best climbing and rappelling material. Nylon, because the standard material for the climbing ropes has replaced manila, flax, and hemp and sisal. The military mounting critical application rope is constructed in the laid fashion, consequently multiple filament nylon fiber yarn twisted into strands. These strands are twisted into climbing rope with a specific diameter. The nylon laid ropes are easiest inspection serviceability with the twist in the fibers. Laid ropes intended to run twisting slightly under the load, causing kinking or spinning. They are also susceptible to abrasion. The following specifications pertain to the standard military nylon laid climbing rappelling rope. 36.5 meters or 120 feet long. The 11 meters or 7 of an inch wide. At least 4,500 pound tensile strength. Right hand lay and 1/3 stretch factor at point of failure. May lose as much as 15% of the strength, and when wet, and weighs 6 pounds when dry. The nylon 6.1 nylon laid rope, kernel mantle ropes. The ropes are similar to static counterparts, and with the consistent air in corner of the outer sheath, the core is constructed of the continuous twisted nylon filaments, which are laid or braid together with enclosed tightly braided outer sheath. These ropes are well suited for climbing on the rock, or snow, or ice. When briefing the elastic strength, the ropes occur during the fall. They have a stretch about 40% of the point of failure. The breaking of strength is high. There are no exposed strands for the rock crystal to work between the damage of the rope. Figure 6.2. This is less sliding friction through the snap link over all the other surfaces, since their outer sheath is smooth. Kernel manting ropes are available in many sizes, length, strength factors, tensile strengths, and falling rates. Figure 6.2 shows the kernel mantle core and sheath. Figure 6.1 shows the nylon laid rope. 6.2 rope selection. Rope selection in military operations requires rope with various types of lengths and diameters depending on its intended use: static or dynamic, environmental, water repellent, or climbing mission, and lightweight ropes. Other factors: static ropes should have minimal stretch, be smooth, flexible, strong, resistant abrasions and cutting, and have low impact force. The laid rope is easier to inspect by twisting the strands above the part to observe the interior surface. The greater the friction is in holding the knot, is less expensive than the kernel mantle ropes. Its disadvantages include much of the lower abrasion resistance, extremely high stretch factor to both static and dynamic loads, great friction on a rock, readiness to kink, tendency to split, Spin in a free-hanging repeller greater than absorption of the water and dirt. Current mantle rope is easy to work with. It has less friction, does not kink easily, has less susceptible abrasions. Outer sheath protects for the inner fibers from the dirt, abrasions, ultraviolet radiation. Its disadvantages are hard to determine damage to the core fibers, more expensive and laid rope. Current mantle rope is not readily identifiable as dynamic or static and must be marked accordingly. Rope diameter, length, and varying with the intended use of standard diameter from using a 111 millimeters or 7/16 of an inch for stirrups and utility ropes, hauling lines, and 7 millimeter 5/16 of an inch, which also can be used in a double strand and adequate standard. Is to remember that our smaller diameter, the less tensile strength, but the larger the diameter, the heavier the rope. The standard lengths, 36.5 meters or 120 feet, 40 meters or 135 feet, or 45 meters or 150 feet, or 50 meters or 165 feet. Normally, strand lengths should not be cut, and if non-standard length is needed, the rope should be pre-cut before the mission is clearly marked. The rope should be selected for the specific use. There are different types of ropes for various use. The dynamic rope is designed for climbing, while the static rope is designed for rappelling, rescue operation, long haul, and rope installations. Warning: using a rope other than it is intended use could result in personal injury or damage to the equipment. 6.3. Care of the rope. To cover the rope with the propeller lifeline requires a great amount of care and maintenance before the after use of the propeller. The rope should be carefully inspected with excessive wear for the cuts, mildews, rotten spots. If any of these defects are found, the rope is unserviceable, and serviceable rope is destroyed by cutting it into unusable parts. If no section are usable, the rope is cut into smaller parts and discarded. Ropes should never be spliced together, stepped on, dragged, or this could greatly reduce the tensile and strength of the rope. The rope must not come into contact with sharp edges. If this is likely, the areas must be padded with the tap before rappelling. The rope must be kept as dry as possible. If it becomes wet, it must be dried out to prevent rotting, avoiding excessive heat or heating during the drying process. Alright, 6.4 coiling. Two methods for coiling of the mountaineer's coil and the farmer's coil. Figure 6.3, the mountaineer's coil. To use the mountaineer's coil, grasp the rope with a route of 3 feet from the end of the left hand to the right hand, then place it next to the left hand and run along the rope until both arms are outstretched. Grasping the rope firmly with bring the whole hands together to form a loop, which is laid in the left hand. Repeat the forming uniform loops that run into the clockwise direction until the rope is completely coiled. If the rope tends to twist to form a figure 8, and tends to twist or form a figure 8, gives a slight twist with the right hand when each loop is formed, and coil the rope at a clockwise direction to conform with the lay. 2. A complete coil from a bite about 6.30 centimeters or 12 inches long with the strength end of the rope. Lay it among the top of the coil and uncoil the last loop. Use it as wrap around with the coil and bite. Wrap toward the close end of the bite and binding the final wrap across itself and locking it into place. Make 6 to 8 wraps to secure the coil, pushing the end of the rope down from the closed end of the bite. Carrying the running end of the coil and either the back of the by forming a figure 8, doubling it up or placing it under the flat. Place it over the shoulder and under the opposite arm. If the rope is to be coil is anchored as in coiling at below the rappel line, shut the coil near the end of the end closest to the anchor so that the kinks work themselves out free of the free end. Farmer's coil. The farmer's coil is easier and faster than the coil than the mountaineer's coil. Establish the center of the rope either by locating the center mark of the grasping at both ends of the rope, feeding them out until the bite comes up to the center of the rope, beginning with the coiling with the double rope, the same as the mountaineer coil method, leaving 4.6 meters or 15 feet of the rope uncoiled, then squeezing this coil together, making 4 to 6 wraps around the middle of the coil, ensuring that the first wrap is held in place by the other wraps. Form a bright or 2 running ends of the base and through the bite. Form the top of the coil, then run the 2 ends over the top of the coil through the bite that is formed. Address the center of the back of the carrier. Run the 2 ends of the over shoulder to form the shoulder straps. Then bring them under the arms and cross them in the back over the coil. Bring them around the body of the carrier. Tie them off with the square knot at the stomach. All right, your mountaineer coil shows 1, 2, 3, and 4. Your farmer's coil shows the is below that. It's you can see like in the farmer's coil, you can make it so it has back strings for you. The Mountaineer's coil is like a wrap or coil, and then wrap, and then a wrap, and then like another wrap. The snaps are used to join equipment to the rope with the people in the function system when they used properly. They are strong, versatile. Snap links are metal and steel, aluminum alloys, loops with hinges, spring-loaded gate on one side of the comes in many sizes, shapes, strengths, with or without locking gates, and many types of metals and steel. The stronger snap link is but is heavier. Alright, 6.5, the description. Snap links are available to many sizes and shapes of the suit the different needs. The locking snap link is best for repelling. Non-linking snap links are easier to operate but should be avoided. Be used only when they cannot be accidentally opened. Hollow snap link should be avoided since their use is limited. The following information applies to all snap links. The weakest part of the snap link is the gate. The gate must be closed before applying the load. When the gate is open, the snap link should have little or no lateral movement of the gate. Lock pins should be checked to ensure that they are not loose, worn, or corroded. The metals should be checked for any cracks or grooves, burrs, flaws, or rust. The spring-loaded gate should be automatically closed securely from any opening to a closed position with no gap between the locking pin and the notch. If the engraver is used to mark the snap locks, it should be applied only to the gate, never to the load-bearing side. If a snap link should never be side-loaded across the gate, since this reduces overall strength to the point of the gate of failure. Alright, two types of snap link. There's two types of snap links during the military operation under standard snap link figure 6.4 and the locking gate snap link. Both snap links are available in D-shaped variations or oval variations. Figure 6.4 shows the standard snap link oval with the locking notch gates, locking pin, and hinge. Figure 6.5 shows a D-shaped snap link. The D-shaped snap link are stronger than overall oval type because the shape directs the largest part of the load to be applied from the longer side of the strong side of the opposite gate. The D-shaped snap links are made with steel, aluminum alloys and are available in many sizes, thicknesses, all which may come with or without locking gates. Their strength and durability vary when they must be considered before using oval links. Oval links are versatile and have different applications. They are made with a steel aluminum alloy. Aluminum alloys are available in many sizes and thickness, but sides of oval by both sides of the oval snap bear in the strain equal under load weight. Many modified ovals are available must be and can be with or without locking gate, although must meet the military standards or the UIAA specifications. Locking snap links. Locking snap links have the locking mechanism with the thread sleeve on the gate. The sleeve screws tightly over the gate, opening the end of the hinge and to hold the gate closed. A reverse locking gate is needed to prevent the moving of the rope and from unscrewing the sleeve. The locking sleeve and the threads should be kept free of the dirt and grit. These sleeves is forced to close. It may strip the threads. The locking mechanism ages and weakens after repeated use. Should be routinely inspected for wear. The characteristics of the lock snap links are as follows. Material steel, approximately strength 2,000 pounds with the gate closed. Gate spring loaded without locking the sleeve. And weight of 4.3 ounces. This figure 6.3 shows a locking spring link. Alright, 6.7, inspection. All repelling material and individual repelling equipment must be inspected before conducting repelling operations. The repel master is responsible for ensuring the serviceability of repelling material and individual repelling equipment. Snap links should be inspected daily before, during, and after use. The metal should be checked for the cracks, grooves, burrs, rust, flaws. The gate should open and close freely without binding. This no lateral movement. The gate is open. The gate spring action should snap when released. The locking nut should have the slant and slot of the gate remains and should, under the impact of the propellers fall. The gate pin should not work with a way out of the holes and should not be shorter than their holes. If there is a locking mechanism, they should be inspected to ensure the threads are not stripped of the sleeve of the tight lock gates. If the burst and groove of the rough areas identified with the snap link should not be noticed, the rust should be removed with the steel wool and spot rubbed with the oil and solvent. The spring should be lubricated as needed. The snap link must be boiled in water for 20 to 30 seconds to remove the cleaning agents, since the solvent and oils can cause dirt to cling to the snap links to rub off the oil, and to rub off on the ropes. It's better to use the dry graphite-based lubricant on snap links, since such lubrication does not attract dirt. ropes. The ropes are inspected with the serviceability. Rappel rope is unserviceability is saturated with the petroleum products as mildew. Shows excessive wear. Has soft spots. Internal damage. One strand is cut more than one half. The diameter of the rope should be inspected daily before, during, and after use. The applicable notion should be made with the corresponding rope log DA form 5752R figure 6-7. Figure 6-7 shows example of the copy form completed for F5752R rope log usage and history. Alright, gloves. The gloves are inspected with the serviceability. They're unserviceable if the helmets are found. The gloves are inspected with the serviceability. They are unserviceable if the holes are found with the friction bearing with the surface or along the seams. The helmet is inspected with the correct assembly. Serviceability is unserviceable if cannot be properly assembled. If any straps are cut and torn, 1/4 is the width. Ensure that the chin straps attaching the tabs are secured to the helmet by locking the nuts. Ensure that pull the dot tab has 4 piles nylon that the chin strap and is routed from the inside of the buckle around the horizontal bar on the back toward the inside of the buckle. Section 3, alternate method of descent. Snap links and carabiners are used for rappelling and replaced with their sewn loops of the seat harness from the sewn loops of the seat chest combination. 6-8 shows a figure 8 descender. The rappel attached to the locking cabinet to the harness. Figure 6-8. He routes the propeller rope through the large hole, places the bidder over the collar, and he inserts the figure 8 to the rappel rope attached to the locking cabinet. When it locks it down with the rappel brakes and the repair to descend into the seat hip rappel. If the heavy loads are to not be descended, he uses a double wrap around the collar. This shows the figure 8 descender. Figure 9 shows the Muttner hitch. The repeller attaches the large radius spin link harness to the rappel seat. He ties the Muttner hitch to the clip into the snap link. He braces to the front end to descend with the L-shaped body position. Note that the guy hand should remain on the standing end of the rope to keep the propeller's head facing away from the hardware. The Muttner hitch creates a significant rope-to-rope friction and may cause premature wear on the nylon. This shows the type of the knot with the Muttner hitch across these. Chapter 7, knots.